All right, hi Phyllis, welcome back to more on particle motion. It says, on what intervals of time is the particle speeding up? When is it slowing down? Explain your reasoning. So we talked about speed before. We said it's speeding up when our signs are the same, and it's slowing down when our signs are opposite. By signs, I mean the signs of velocity versus the signs of acceleration. So if we look at this guy here, where is our velocity positive and our acceleration positive? So let's first talk about our velocity is positive here between 0 and 2, and our acceleration is only positive, though, between 0 and 1. Between 1 and 2, it's negative. So we're speeding up between just 0 and 1. That's when my acceleration is positive and my velocity is positive. Whoops. So we can say the particle is speeding up between, actually let's just say on 0 and 1. All right, what else? This is our other possible case where it could be both positive. So between 7 and 10 we're positive, but over here we're only positive between 6 and 8. So between 7 and 8 we're positive. After 8 we go to being negative. So my velocity is positive between 7 and 8. My acceleration is positive between 7 and 8. So that's another one. I probably skipped one. So let's look at, is there a place where they're both negative? So we're negative between 2 and 7. Between 2 and 7, is my acceleration negative? Yes, my acceleration is negative between 2 and 3. And then again after 8, but that's not what we're worried about. We're just worried about between 2 and 7. So between 2 and 3, they're both negative, and so we would be speeding up. So we'll say here, and between 2 and 3, because V of t and A of t have the same sign. They're both positive, or they're both negative. All right. When are we slowing down? We can say the particle is slowing down anytime. Oops, the particle is slowing down anytime that the velocity and acceleration have opposite signs. So we said 0 to 1, they have the same sign. So between 1 and 2, they're going to have opposite. 1 and 2, velocity is positive, but acceleration is negative. Our first interval, it's going to basically be the opposite intervals of these guys. So between 1 and 2. 2 and 3, we said were positive. So I'm guessing between 3 and 7, they're going to be opposite. Let's go investigate that one. So between 3 and 7, my velocity is negative. But between 3 and 6, it's 0. So that's not going to be negative. Between 6 and 7, though, here, we're negative, but our velocity is positive. Right? So remember at 0, we're neither speeding up or slowing down. I messed this one up. This should be between 6 and 7, right? Because between 3 and 6, I forgot to take into account, between 3 and 6, our acceleration is 0, which is neither positive nor negative. And then our other spot would be between 8 and 10. My acceleration is negative, and between 8 and 10, my velocity is positive. So that's going to be the other location. So between 8 and 10, and this is because V of t and A of t have opposite signs. When they have the same signs, we're speeding up. If they have opposite signs, we're slowing down. All right, definition of net distance versus total distance. So the net distance is the distance from where the object begins, so when it begins to move, and where it ends. That is our net distance. All right, what about total distance? This is the sum of all distances moved. That's weird. The sum of all distances moved in any direction. All right, so let's think about what that looks like. So if I have a particle, right, and it starts here, and say it moves to the right, moves to the left, moves to the right, moves to the left, and it ends up here, this distance here is going to be my net distance. Even though it moved here, and then here, and then here, and then here, this is my net distance. But if I'm looking for the total distance, well, the total distance would be the amount from here to here, plus this piece here, plus this piece, and then we said it moved back to here, so plus this distance, plus this distance. So we would add up all these guys once we measured it out, this one plus this one plus this one plus this one, that's total distance. The net distance just says, okay, if I started here and I ended here, how far away is that one? So your total distance a lot of times is going to be a lot bigger than your net distance. It says if a particle is moving in the same direction the entire amount of time, what can be said about the net distance and the total distance? So this was the case when we moved back and forth. What happens if I move this way? I speed up, I slow down, I speed up, I slow down. What about our net distance and our total distance? Does it change or are they the same? They're the same because I never backed up, right? Your net distance only comes into play if you're going two different directions. If you're going in the same direction the entire time, the net distance will equal the total distance. All right, to find the net distance of a particle, travels on an interval. So on the interval AB, this is a closed interval AB, the net distance an object travels sorry about my writing here, an object travels is the absolute value of P of A minus the absolute value of P of B, where P of T is the position function. Right, what does that mean? That's a lot of words. What does that mean? What he's saying is the net distance is just you take the value of my position at time A, the value, and subtract off the value of the position at time B. So I could do all sorts of things, but all I really care about, if time A I'm here, time B I'm right here, I'm going to take this value and subtract off this value. All right. And we want the absolute value of it. What does absolute value mean? Remember, it always gives us a positive value. So if we're talking about distance, we're not going to have a negative distance. It's always going to be a positive distance. All right, to find the distance of a total distance of a particle that travels on an interval. All right, so provided the object moves the same direction on that closed interval AB, total distance is going to be the same thing. It's going to be the absolute value of P of A minus P of B. But if the object changes direction, at, say, t equals c, that's on the open interval b, then the total distance is equal to the absolute value of p of a minus p of c plus p of c minus p of b. And we're going to look at that in the next example. And we've got a couple of examples to calculate net distance versus total distance, and that'll be on the next video number 3.